Okay, good morning. So welcome back, and let's continue with another exercise today. So just I updated your uh, assignments grades, and so okay, so I graded everything since from example 4 or 5 on. I think I put grades up for those, and so there's uh, this the ones from last week are not due until today, so I still have to update the grades on those two. Example 5.5 and 5.6, and example 5.7. But you should see that if you turned in the assignment, you have a grade unless you just turned in the last two assignments. I have to update those. And then also I started putting, because there's getting to be a lot of assignments. I think I put your total number of assignments completed. So if you look on Blackboard, you should see a grade called this. So it's called something like that, and I wanted to count the number of total assignments so you can keep track because they're starting to add up. And so I think we've done 14 so far after including today's two assignments. So by tomorrow morning there'll be 14 assignments due. Okay, so double, and then if you look on Blackboard, you can see which ones that I have you not turning in if you've missed any. So if you've got if after today, because there's two more assignments, you still have until the end of today to do the last two assignments, 5.6 and 5.7. So you should have 14 due if you've done them all. And so if you've done 14, then I believe that you've done all your assignments, which some of you have. And if you've missed any, then you should be able to see which ones you've missed. All right, and I'll have some more. I'll have some more extra credit opportunities to make up for any assignments that you've missed. But double check your grades and let me know if you have any questions on that. Okay. And I think we've had one extra credit so far, and so if only a few of you did it, but if you did it, that just counts as like an extra assignment. And so if you did that, and so the point is you can't get more than 100% of the assignments, but if you do an extra credit, you might as well do it because just in case. So you might have an extra point from an extra credit, and that's how that works. All right, so today, all right, so we're done with the network models in chapter 5. The next chapter I want to cover, we have a couple more chapters. Example, chapter 14 and chapter 10. All right, and so I want to do chapter 14 first. And so we're going to jump to chapter 14 in the textbook. And so example 14.1 is what we'll do today. And so if you go to the Blackboard page, okay, we can open up the example 14.1 document and then the exponential growth Excel file for today's exercise. Okay, so today we're going to look at a simple time series example and a simple forecasting example. So time series. So time series data is pretty simple. Time series data is just one variable that changes over time. And so in this example, we'll have some data on sales for a company, and we're going to look at how that changes over time, and then use the behavior of that data to see if we can make some predictions for the coming future years or future months. So let me read the description for today's exercise. Okay, actually, I thought this was computer chips, but I guess it's potato chips. So the Best Chips company, potato chips, produces and sells potato chips throughout the country. Its sales have increased steadily over the past 10 years, as shown in figure 16.2 and the file exponential growth, which is the one we're looking at. So year one is 1997 data, hypothetically, and then so on. And so the company wants to predict the sales for the next couple of years, assuming that the upward trend it has observed in the past 10 years will continue in the future. So how should the company proceed? All right, so what we're going to do is take a look at the data graphically and then use some different mathematical equations or prediction models to see which one appears to predict the data the best. And then the one that does predict the data the best, or at least appears to, we're going to use that to make a couple predictions for year 11, or year, I think it's, yeah, year 11 and year 12. Okay, so let's go to the Excel file. There's not much on it, just a list of data for this Best Chips company. Okay, so go to the exponential growth spreadsheet, and all you're going to see is a list of years, 1 through 12, and then the sales observed data. So this is the sales data in year 1. This is the sales data in year 3, or year 2, and then so on. So we're going to use this observed sales data and see if we can get our best guess for what might happen in year 11 and year 12, all right? So that way the company can plan accordingly, assuming that the sales trend continues, which we're assuming it will. All right, there's a quick little video that you can watch when you get a chance on time series. It's a nice little 10-minute or so explanation on that. So take a look at that. And here we go, forecasting sales at Best Chips. So this model is a little bit different because we don't really have a decision. We're not going to use solver today. We're just going to use the trend line option. So step one is just to fit a linear trend line. So first, let's just create a scatter plot of the data and see what it looks like. All right, so to create a trend line, just I think we've done this before with that golf club example one. So we're going to kind of build on those techniques. Okay, so if you want to select all of the data, A1 to B13, including those two blank cells, because we're going to extend the line for the prediction years. So select A1 to B13 and then insert. Okay, so insert, and it's not under recommended charts. So we want the scatter plot. All right, so there should be a little icon or option for scatter, and just click on that. And we want just the regular scatter plot. See that? All right, so the first step is just to get that scatter plot. So let's start with the scatter plot, and then we'll go from there. So was everyone able to get the scatter plot of sales over time? Okay, great. So so we're going to do, if you look at the Word document, we're going to do two different types of equations to see which one is the better. So we're going to do a linear trend line, and we're also going to do a exponential trend line. All right, so the first thing we'll do is format this a little bit and then copy and paste it so we can have two duplicates. And then we'll use one for the linear and one for the exponential trend line. So first, let's do this. Let's add, well, first of all, let's see how the bottom thing is. Yeah, that doesn't correspond with what our years are. So let's fix that. And to fix that, to say 1 to 12 instead of 0 to 14, click on the x-axis like I have, and then right-click it. All right, and then click on Format Axes, and then just change the minimum to 1 and the maximum to 12. All right, so the minimum is 1, the maximum is 12, and go in increments of 1. All right, just so see how it looks exactly like the years over here. Okay, so if we got that, we can add axes titles. So click on the chart. Yeah, sure. So let me go back and I'll do it again. Yeah. All right, so the first thing you want to do, I went back to the original, is just click on the x-axis and then right-click it with the mouse or with your whatever touchpad it is. All right, so there you go. Click on it and then right-click it, and then go to Format Axes. And then once you're over here in Format Axes, just change those options to see where it says bounds, change the minimum to 1 and the maximum to 12. Okay. And then, yeah, and then major to 1 unit. Never mind. Okay, you're welcome. Okay, next thing we're going to do is add a title to show that the y-axis is sales and the x-axis is the year. So click on the chart and go to chart options. The plus sign is chart elements, and then there's an option for axes titles. Click on that. Okay, so change this axis title to sales. And then change the x-axis title to year. So you can see that the sales are increasing or trending upward each year. Okay, so there you go. That looks a little bit nicer. You can see what the axes are and what the years are, right? Okay, and then let's put it down here because let's put it down here because I think we're gonna do we're gonna add some data. So I'm just gonna drag it down here. All right, and then let's copy and paste it because we're going to use one for the linear and one for the exponential. So just click on the chart and hit Control C for copy. And then just click a cell to the right of it and hit Control V for paste. And so all you want here is just two copies of the same chart because we're gonna do two different trend lines. So we got the scatter plot formatted over time, and we got two copies. And then one of them we can label it the linear. Okay, and the other one we can label it the exponential. So see that? Is everyone good so far? Do we have the two formatted scatter plots? And one's the linear and one's the exponential. So let me know if we're good here. Okay, so we're still on step one. So let's format a linear trend line. Okay, so let's add a linear trend line. Let's choose the linear option. Let's enter 2. There's a little forward box so we can extend the line for 2 years, which is what we're trying to do, make a simple forecast. And let's also display the equation on the chart, okay? So let's do step 1. So go back to the spreadsheet. And click on this one that you gave the title for linear, and click on the plus sign for chart elements. And then down where you see the trend line, click on that little arrow for more options. Or click on the arrow and then more options. Okay, so like that. So plus sign, arrow for trend line, and then more options. Okay, so we want the linear one. You can leave that. You want to forward it 2 periods. So put a 2 there, in the forward box, and then there's an option for display the equation on the chart, and click on that. All right, so when you get to this trend line options, you want linear, forward 2 periods, and then display equation on chart. Okay, and if that worked, you should have your, see here's the trend line. It's extended 2 periods for 11 and 12, and then you get the equation right there. Okay. All right, so the next step is just to, did we get the trend line? Okay, so if we got the trend line for the linear, the next thing to do is format it so it's not those weird numbers. And so you can just right click it and click on format trend line label, and then click on number with 2 decimals. So back to the spreadsheet. Okay, so click on that equation and then right click it. And click on format trend line label. And then when you're here, just change the category to number. And so I think I said 2 decimals, but I meant 0. So change it to number with 0 decimals. And we can close that. Okay, so there we go. We got the linear trend line with the extended 2 periods, and then we got the equation there. All right, so okay, then the next step is to do it for the exponential. Okay, yeah. So I think that's going to be that noise will be done soon. But sorry about that. Maybe not. Okay, so step three. Okay, so let's do this. Let's do step three. Let's do the same trend line analysis with a different type. And so for step three, we're going to format, just like the title says, we're going to format an exponential trend line instead and do that. So go back to the spreadsheet. And then click on the exponential one, and then click on the plus sign. All right. Okay, and we're going to choose the little arrow for trend line, and then more options. So again, for the exponential scatter plot, the one you titled exponential, the second one for the copy, click on the plus sign, then the trend line arrow, and then more options. Okay, and we're going to choose the exponential option here. See that? And then again, we want to format or forward two periods, and then choose the display equation on chart. Okay, so once you get here for the format trend line, the options you want are exponential and forward two periods, and then again display equation on chart. All right, so then we get that equation. So see how we get this trend line for the exponential with the equation that goes with that. Okay, and then if we've got that, the next step is just to format this so it's a little bit easier to see. Okay, so you can click on the trend line for the exponential, right click it, and then let's do the same thing, but let's format number. And this time let's use 4 decimals because we need those extra decimals for the exponent factor. All right, so click on the trend line equation box for the exponential, then right click it. Then format trend line label again. And let's do number, but with 4 decimals because we need those extra decimals to get the effect of the exponential. So number with 4 decimals. Yeah, no problem. So let's do the trend line for the exponential. Let's do that one more time. Or you mean just the formatting part? Okay, yeah. Okay, sure. So let's. All right. So you wanna click on the trend line label equation here. All right, and then right click it, and then go to format trend line label. And then once you get here, you want to change the category to number and the number of the decimal places to 4. So format trend line label and then change it to number with 4 decimals.
Got it. Thank you.
You're welcome. Okay, so there we go. All right, so everybody good so far? I think the leaf blowing is done. So that's, I promise you that was louder for me than for you, but I think we're done with that. Okay, so we've got a linear trend line. All right, and you can see that here's the trend line, and it extends 2 periods. So if we chose that one, then like that would be those would be our next 2 predictions. All right, there's the equation, and then here's the exponential. That one looks pretty good. And if we chose that one, this looks like the next prediction, and that looks like the next prediction. So we're going to take the equations that were estimated, see which one captured or measured the historical data, years 1 through 10 better, and then use the better one to extend it for our prediction for the next 2 years. All right, so we need to add a few like titles or headers, whatever you want to call it. So let's see how this. I took a screen cap of the textbook so you can see it, but you want to make some labels, and then we'll make we'll put the equations under those labels. So in D1, let's call this predictions. Okay, and if you want to make that bold, then the Control B option makes it bold. Okay, and then in F1, let's call that absolute percentage errors. Okay. The title of F1 is absolute percentage errors, and again, Control B, as in boy, makes it bold. Or you can just hit the bold button up here. And then let's bring this down one. So the years line up the same. Let's bring the data down one cell over on the left, and let's add the title historical data there, just like it shows in the spreadsheet. So it'll look a lot easier when the years line up. So go back to the spreadsheet. All right, and this should work fine without doing any messing up to this whatever it's called, the trend lines. So if you select A1 to B13 and just cut and paste it, so hit Control X is cut. Okay, Control X for cut, and then I just want to move it down one row. So if you cut that and then just click on A2 and hit Control V for pasted, I'm just trying to move it down one. All right, so all I did there was select all the data and then cut it and paste it, just move it down one. All right, so hopefully, did that work? All right, and then you can, Excel is pretty knowledgeable or smart, and so Excel knows if you move something that it's going to continue with that selection. So see how the charts are still selecting the right data if you move it down one. Okay, and then if that worked okay, let's give this title in A1, let's call this historical data. Okay, and you can bold that. And then we're going to put the linear predictions over here in D and E. Okay, so in D2, just title that linear, and then in E2, title that exponential. All right, and then again in F2, let's call that linear. And then in G2, let's call that exponential. So we're just setting up what we're about to do. All right, and then one more label before we start doing the calculations. So in row 16, we're going to calculate the MAPE after we do the absolute percentage errors. So in E16, right there, let's call this MAPE. And you can bold that for the future coming mean absolute percentage errors. Remember, that's just the average of the percentage errors. All right, so your spreadsheets look similar to mine. So is everybody good on this, the setting up the titles here and moving the data down one? Okay, so the next step is to manually type in the equation in the formulas, and then we'll use it to calculate the data and the predictions for the both types. So step 5. Okay, so let's put the equations that we get from the linear trendline equation and use that to get the estimation, and then we'll use the same formula for all the other years. All right, and then again, then after that, we're going to type in the equation for the that we got from the exponential trend line and use that to make our predictions for the exponential. All right. Okay. So starting in D3, let's manually type in our equation that we got from the exponentials. Sorry, for the linear. All right, so we're typing in that equation that we all got hopefully from the linear, this one here. So in D3, the equation is equals all right, the equation is 1,168,200 plus 92,091 times A3. So you can see that we're exactly typing in this equation right down there for the linear and using it for in a time series. The x values are just time. So x1, or the first x, is just the year one, time period one. So your equation again is equals 168,200 plus 92,091 times A3. Okay, and we should get 1,260,291. All right. And then let's type in the equation for the exponential, and then we'll apply the equations down for all the other years or x variables. So in E3, let me see if I can bring up this equation. All right, so in E3, we're going to type in the equation that we got for the exponential trend line. All right, so in E3 equals all right, so I think that's it, but we're typing in this equation. So see, the equation is equals 1,227,762.1725 times exp. That's the exponential, the e. And then in the parentheses, 0.0541 times A3. All right, so see the equation that we should have gotten for the exponential right there, we're just typing in that, and our x variable is year one, which is A3. Okay. So if we got that, we can apply those same predictions to the other years. So if you've got those two equations that we just typed in, go ahead and select D3 and E3 together, and then let's just grab the bottom right corner and drag it all the way down to get years 2 through 12 predictions. All right, like that. And then while we have it selected, let's go ahead and format this to be actual currency with the dollar signs and the commas. So if you did that, then leave selected D3 to E14 and format that to currency.
Sorry, Professor, could you please do it again? My number is different with use.
Sure. So what, the linear, the exponential, or both? Which one?
Right now, I get the similar with you.
Oh, so this one's different?
This one is also similar, but their number is different.
The linear is different?
Yeah.
Oh, okay. So let's see. So, well, it's got to be this. It's got to be the same if you type in the same equation because the x variable is just one. So it should be equals 168,200 plus in the parentheses 92,091 times A3. And that's
Yes.
A3, but is A3 year one?
Yeah.
No, you don't get this?
I didn't get that.
What did you get?
My number is 1352382.
Well, that's strange because well, okay, so let me look. You want to post yours and I'll look at it?
I just keep doing. I think I may miss some step.
Okay. Well, if you post it to example 14.1, I can look at it if you want me to.
Sure.
All right. Well, I'll do a few more steps, then when you post it, I'll come look at it.
Okay.
Good. All right. So we'll apply the formula down and then do the formatting. So if you've got the equation here for the linear and the equation here for the exponential from step 5, then you can select them both. If you haven't done so already, so you can select D3 and E3, then grab the bottom right corner and drag it down like this. Okay, so when you get the predictions for the linear and the exponential, and then if you have D3 to E14 selected, you can format that. So Home tab, and then Format. And then Format Cells. And you can just change that to currency with 2 decimals and the dollar sign. Actually, let's have no dollar sign because this is the numbers are getting big. All right, so Home tab, format cells, and then currency with 0 decimals. That's going to be easier, and with the dollar sign. All right, so there you go. We got those numbers or those predictions for the linear for each year, and for the exponential. See how the last two should be corresponding to year 12. Okay, so same equations, just different x variables.
Got it. Thank you a lot.
Oh, you got it? Okay.
Mm-hmm.
All right, so everybody good on this stuff here? Okay, so step 6 is to calculate the absolute percentage errors, and this is simply how far off the prediction was from the actual piece of data in percent terms. So was it 1% off? Was it 2% off exactly, or et cetera? All right, so let's put in that equation for the absolute percentage error in F3, and then we can copy it to the rest of the range. So let's go back to the spreadsheet. Okay, in your equation for step 6, in cell F3, type in all right, equals ABS for absolute value, just take away the negative. So equals ABS, and in the parentheses, $V3 minus D3 divided by $B3. So it's the actual data minus the prediction divided by the actual. So what was the difference over the actual? All right. Okay, and so hit enter. And then we're going to use the same formula for the rest of the range under the absolute percentage errors. So you can drag it over like this. Okay, and then you can just leave selected F3 and G3 and grab the bottom right corner and drag it down to get all the other absolute percentage errors. All right, so drag it down to get the range F3 to G12, and then with that selected, you can format it to be percentages. So you can see what the actual percent off is. So you can go ahead and here's the on the home tab, there should be a little drop down here for general. All right, and if you see that, you can just change the format shortcut to percentage. And these are all the absolute percentage errors in percent terms. So like,
Could you please do it again?
sure, yeah.
Thank you.
So you got this equation in F3, which is equal to ABS in parentheses $B3 minus D3, and then divided by $B3. Okay? And then grab the bottom right corner of F3 and drag it over to G3. Okay? And then we're going to just apply it down now. So with F3 and G3 selected, grab the bottom right corner and drag it down to get years 1 through 10. Okay, and so we've got now the absolute percentage error in range F3 to G12. And then all I did next was just format it to be percentages. So if you have the home tab, you should see this drop-down formatting option up here, hopefully. And you can change it from general to percentage. Okay.
Got it. Thank you a lot.
You're welcome. All right, and so what these numbers tell you is like, this is the linear prediction, this was the actual data, and we're saying that this was about 6% off from that. All right, and so the lower it is, the closer it is to the actual data. All right, so see, this is 1,352. This is 1,352 something, so that one's really close. The percent off was only like 0.03%. Okay, and so these are the actual percent offs in absolute value terms for all the predictions compared to the actual sales data. Okay, and the next step is to calculate. Oh, you have a question? Oh.
Yeah, I have a question. So for the absolute percentage errors, how do you get it to show 2 decimal places?
Oh, so did you change it to percentage?
Yeah.
Okay, so let's see. Okay, so if the default wasn't 2, then there should, see these things up here? It says like decreased decimal and increased decimal.
Yeah, I was hitting that. It wasn't doing anything.
Oh, it doesn't increase the decimal?
Yeah, it doesn't let me do it.
Well, another way to do it is, so if you select,
I
yeah,
actually just got it. Never mind.
okay,
Yeah, sorry about that.
no problem. Okay, so the next step is to calculate the MAPE, which is just the mean absolute percentage error. So that's exactly what it means. It means the average of or the mean of the absolute percentage errors that we have here. So step 7. Let's just calculate the average of both ranges of APEs and see which one has the lower average. So in F16, the equation is equals average. Of F3 to F12, so the average of all those 10 linear APEs, and answer. So on average, this is telling us the linear model, the linear trend line was about 3% off of the actual sales data. All right, and that looks about right if you look at the graph. Yeah, okay, so I'll buy that. And then you can do the same, get the MAP for the exponential, just grab the bottom right corner of F16 and drag it over like this. And this should be the average of the 10 APEs for the exponential. So average G3 to G12. Okay, and this is saying that on average, the exponential model was only about 2.39% off. All right, and that looks right. So you got, yeah. Okay, so if you got that, the question now is just to evaluate it, which is pretty simple, but so now which trend line is better? And then therefore, what should be our sales predictions for the better trend line equation? So, all right, so did we get those MAPEs for the mean absolute percentage error for both types there? Did we get those? All right, so which one is better?
The linear better?
Well, you want the one with the lowest error, right? So this one would tell you that, yeah, right. So the exponential is better, obviously, if the linear is not. So yeah, it's the exponential because this one wasn't bad. This one was about 3.14% off, but this one was only 2.39% off. So if it was like 0%, that would mean it was 100% accurate. Yeah. So the lowest percentage error for the exponential, like Kayla said, is the one we would choose based on these two types. So this error is lower than this, which would mean that over the historical data, this one modeled the data better, right? So given what we've done with just these two types, we would choose this one. It has the lower error, so I'll just highlight that. And then if that's the case, our predictions would be those predictions from the exponential. So the exponential says that in year 11, this would be sales. And in year 12, this would be sales. All right, so in year 12, or sorry, year 11, if you extend the exponential trend line, the prediction would be 2,226,193. And in year 12, it would be 2,349,948. So that's just taking that line and extending it to year 12 right there, and then year 11 and year 12. So those predictions would come from the exponential. So I wonder if we can, no, we don't need to do that. Okay, so yeah, that's what we did here. And we did a simple analysis of the time series data and used two methods, linear and exponential, to see which one might have captured the data better. In this case, it looks like it was the exponential. And so just given these two options, exponential is better. So the predictions using the exponential are these ones. Okay, so everyone got that for this exercise here? Okay, so excellent. All right, so we're done with this spreadsheet portion, so you can save exponential growth. All right, that's example 14.1. That goes in there. That's due by next Tuesday. All right, so I have a practice problem I want to go through for this one, but we're done with the spreadsheet part. Okay, so save that, and if you're done with it, or whenever you're done with it, put that in example 14.1. All right, so let's go ahead and look at the practice problem. So I had a practice problem on example 14.1, which is from a previous midterm. So midterm exam 2 for fall 2018. And let's look at that one. I have that on the other document. So this will be a possible type of question on the upcoming midterm. All right, so under example 14.1, example 14.1, practice question 1 solved. Open that. All right, so we got, here's our absolute percentage error equation. Here's a screen cap of something similar to what we just did, but the sales data is different. Okay, so you got some predictions for the linear, the exponential, and then the absolute percentage errors. And here's the equation for the linear part, and then here's the equation for the exponential, okay? And you have some questions that go along with this. Number 1, okay, so we refer to the screen cap of exponential growth, and using the linear model, calculate the APE for year 10. All right, so I just want you to make sure you know how to do it based on what we did in the example. So the APE, the equation's given. All right, it's just the actual minus the predicted over the actual. So in year 10, you got to calculate these two boxes. So the actual was 2,200,000, and the prediction for the linear was 2,075,453. So the absolute percentage error is just that minus that over that, and then you can just multiply it by 100 to get percent terms. Okay. So here it is. There's the actual minus the prediction divided by the actual. That gives us, in percent terms, 0.0566, but or in decimal terms. But if you multiply that by 100 just to get it in percents, it's about 5.66%. All right, part B. Using the exponential model, calculate the APE for year 10. So this is the same process, but you want to do it for the year 10 data for the exponential. Okay, so here's the year 10 prediction for the exponential, 2,094,105. So let's see how far that was off from this. All right, so you're calculating this number that's missing. Okay, so the APE for year 10 for the exponential is actual year 10 minus prediction exponential year 10 divided by actual year 10. And that was approximately 4.81%. And assuming you did the APE is correct, C, which model predicted the sales data better for year 10? And that would be here, the exponential model, because its APE was less than the APE for the linear, right? So 4.81 is less than 5.66%. So you would choose for this year the exponential. And part D, calculate the predicted sales for year 11 using the linear trendline parameter. So here, just take the equation you got from the trendline and put in the x value, which is 11. Okay, so y equals 91,212 times x plus 1,163,333. So that's your equation. And just plug in the x you want. In that case, x is time, so x is 11. Okay, so you got 1,163,333 plus, I'm just using the equation that was given, 91,212 times x, and x is 11. And if you put that in a calculator or whatever you want to do, you get something like 2,166,665. All right, then part E, you can just calculate predicted sales using the exponential trendline parameters. So take the one for the exponential. Okay, it's a big number, but it comes out nice. So the equation is y, or sales, equals 1,223,36.107 times e, all right, exponential, raised to 0.054 times x. And again, x is time, so x for year 11 is 11. All right, so see how the x's are just the time point. So use that equation and plug in 11 for year 11 for x. And that gives us 1,223,36.107 times e raised to 0.054 times 11. And that gave us about 2,210,296. Okay, and so just the e here is just the exponential mathematical term, which is like 2.12 or something like that, or 2.17. It's about 2.72. All right, and then part F. What does the slope of the linear curve imply exactly? So here, what does that number mean from the sales data, for the linear prediction for the sales data? So if you look at the equation, you get, here's the intercept, 1,163,333, and then this is the slope, 91,212. Okay, so that is the effect of x changing by 1 unit on y. X is year, and y is sales. So what that says is every time we go up a year, this is the average increase in sales. Okay, so that means exactly what it translates to over the 10-year data set. Sales increased by that slope of the linear curve, which is 91,212 per year on average. Okay, so that translates to the annual increase in sales over time that you saw over this data sample. All right, so that's a nice example of how you could, or a nice example from that one. Questions on any of these here? Okay. All right, so I think that's all we have for today. So make sure if you haven't turned in example 5.5 and 5.6 and or example 5.7 to get those in today. Those are due today sometime. And then this one is due next Tuesday, example 14.1. All right, so that's it for this morning. And thanks everyone for coming, and I'll see everyone Thursday morning at the same time. And have a good rest of your week.
Professor, can you help me figure out my solvers?
Oh yeah, no problem. Okay, so do you want to So is it not working on any of the examples?
So what happens is I I start inputting information and then it'll log me out, then kick me out, and then it'll say give me like what I have saved up until I started using solver.
So is this the solver or solver table?
Like the solver table.
Oh, solver table. Okay, so solver table. Are you using a Mac on it?
Yeah.
Yeah. So okay. So I think that it's because it's not compatible with Mac. So this. Okay, so the solver is working fine. This one.
Yeah.
Okay, so that's good. That's all you really. I mean, all the solver table things are pretty much optional now because the solver table that I have available for you guys is not compatible with Mac, and so it's not going to work on Mac. So there might be another. You might be able to find another free version. I got this one from the textbook resources, which is only compatible with Windows, which is what we normally use in the computer lab. And so
Yeah.
that's what. So I made all this. So all the solver table stuff you don't have to do. It's not required. But if you want to try to find out how to get solver table for Mac, then you're welcome to it. But it's kind of up to you. So the solver table that I have is not going to work on Mac, but the solver table stuff is optional now because I that's why.
Okay. So I'll get that screen
What?
and I'll start inputting information to that screen,
Yeah.
and then halfway through, like putting in my first equation, it'll kick me out.
Yeah, it's so the solver table is that I have that you're using from this Blackboard is not going to work on Mac because it's not compatible. And so if you want to use solver table, again, it's optional. If you want to do the solver table stuff, and there's not that much left that we're going to do for it. Actually, I'm not sure if there's any, but if you wanted to do the solver table stuff, you'd have to find a solver table that's compatible with Mac. Which I don't have from this textbook resource.
Okay. So for 5.7 and 5.6, solver and I couldn't.
So for 5.7 and 5.6, what'd you say?
Oh, we use right?
Use solver?
Yeah, for those
Yeah.
assignments.
But let's see.
Yeah, I believe.
Let's see. Yeah, so these ones you just need to do solver, and so solver should work. So did solver work here?
No, like
Oh, so solver didn't work.
yeah, it kicks me out.
Oh, okay. So this is all right. So that's a different problem because so solver table is. I know that's not going to work, but solver should work. So it's hard for me to read this, and I know that there weren't even the students with the Mac are able to run solver. So like when you run solver, it doesn't work.
So yeah, like I'll start inputting information, and then before I even get to answer it, it'll just say, "Oh, an error occurred," and then it'll kick me out of Excel, and then it'll just save all my work up until I started using the solver.
Um, what what Excel are you using?
Let me open it up. It is Excel. Version 14.69, 2011. Oh, yeah. Because I tried to update it and it said there was no updates available. So then I just updated it.
So maybe could you? What if you try using? So I know that there's the student version that a lot of students are using is updated, and it's you can get that for through the school. And
Uh-huh.
so I put. Let me see. I sent an email on that a while ago. So let me see if I can find that. And I think maybe try using the student version that's provided by the school, and that might. And I'm pretty sure they have the Mac version too. And I think that'll work. I think you might just be using an older version. Uh,
Okay.
but it seems like that doesn't seem like that old, but
Yeah, I don't know what the problem is. Because like at first I was able to do it. I just had to input the information in really fast and everything worked fine.
so has Solver been working before or just
Yeah, so like the first it wasn't until like last week that it just started bugging out like this. Which
yeah,
is why I couldn't do like 5.6 and 5.7.
yeah. So I don't know it seems like if it worked before, it shouldn't just stop working. So I don't know like without looking at I'm not great at tech support for Mac without seeing it, but
I'm like,
let me see. Let me find the oops.
I'm trying to find the word. Which one did I do that so I can show you? Was it 7?
Yeah. So the email is if you wanted to try this option, the email I sent to the class on September 8th
Uh-huh.
has the link to the Microsoft Office student version that you can get through the university, or you can maybe just Google it. But if you get here, okay, so if you can see this, all you have to do is type in your school email address,
Uh-huh.
and then it'll Laverne has a contract with Microsoft for Microsoft Student, and you could try that. That might be an updated one.
Okay.
Um,
So just do all the work, do that.
but if it's the only problems you've had have been the last week's assignments.
Yeah.
Okay. Yeah. So just turn them in, and I mean I'll give you full credit because you're having problems with Solver. But if you want to try to fix them, you know, on your own time, just because you, I mean, why not? Try doing this. So get to this page, and you can find the email from that I sent to the class on September 8th. There's
Okay.
a bunch of information there, and here the Microsoft Office student, or maybe you can just if I just Google it.
Okay. Okay. Thank you.
Yeah. So you try this. Yeah, just Google Microsoft Office Student, and you should see this free Microsoft Office for Schools thing. And then all you have to do is type in your school email address, the Laverne one, and then it should give you access to that.
Okay.
For now, just because that one's due today, just turn in those two and don't worry about it for today. But
Okay.
yeah, try this, and maybe this will give you a more updated version. And I know it's a free resource through Laverne, so you might as well try it. So.
All right. So I'll just use that version when I need to use Solver.
Yeah, I think this will be assuming this works. I think this will be a newer version, and yeah, so try that because all the features on the student version I think are all you need here.
Okay. Got it.
And then if there's more problems, then let me know. But I think that should work.
Okay. I got it. Thank you.
You're welcome.
Professor Hoffman.
Yeah.
So I have a quick question. So for the
Sure.
example 5.4 on the discussion board, so I uploaded it right after the class finished, but it seems like it got disappeared, and I think that's why I got a 0. But I have the file here. It's the last edited time is October 15th. So
Oh, so which one is this?
it's example 5.4.
Oh, sure. Yeah. So
I don't know why it just disappeared. Maybe it's
What's your last name?
uploading. Because for the Blackboard discussion board, it actually doesn't give me any like confirmation or anything, so I don't really know if it actually successfully uploaded. But,
Okay. So what's your last name? Oh, this is Jing.
Jingyao, yeah. I don't think it's on the Blackboard.
Yeah. Okay. So yeah, just I don't see it either because in the future, just like after you post it, go back and check and see if it's there. But for this one, just post it, and I'll just post it now or post it today.
Yeah, I'll post it right now so you can check about the last edited time.
Yeah, and I'll give you credit for it because it seems
Thank you.
yeah. So just
Give me a moment.
yeah,
I'm posting right now.
just post it. Yeah, and I'll probably update the grades later this week or this weekend, and so I'll update it when I get to it. But yeah, just post it and you'll get full credit.
By the way, which one should I post? I just I remember last time I posted both files, but there is one.
Yes, because we did. Well, we did. You can post either one. Well, do you have two separate files or did you modify it?
Two separate files. One's called logistic shrinkage, and one just web brand logistic.
Oh yeah. Okay, just post them both. Yeah, just post them both.
Got it.
Like you can post one, and then I don't know if you can post two.
No. So I will just post a follow
So
up.
just post and then reply to it and post another one.
Yep.
Yep.
You should be able to see it now.
Okay. Let's see. This was 5.4.
Yep.
Okay. Yeah, there we go. Okay, so yeah, I'll go through that and yeah, I'll give you credit for that one once I update the grades. But yeah, okay. Anything else?
Nope, that's it. Thank you.
Okay, thank you.
Have a good day. Bye.